What's up everyone, Patrick here, welcome back. And in this next video, what we're told is that you have $10 and $20 bills in your pocket. The number of 20s is 6 more than 3 times the number of 10s. And we're gonna let X and Y represent the number of 10s and 20s respectively. And then given that information, we have these 3 questions here. So number 1, we gotta write an algebraic expression for the number of 10s and 20s. Number 2, describe an expression in words for the number of 10s. So for number 2, I actually noticed that in the question, we're given an expression in words for the number of 20s in terms of the number of 10s. But in number 2, we're going to do the opposite. We're going to give an expression for the number of 10s in terms of the 20s. And then number 3, we got to find the number of 10s and 20s in both of these 2 scenarios. So A, if the total number of bills is 18, and then B, if the total value of the bills is 820. So I'm actually going to start with 1 and 2 together. They're sort of related. So write an algebraic expression for the number of 10s and 20s. So we know that X is what? Number of 10s. Y is the number of 20s, right? So it's easiest, I feel, to start with an algebraic expression for the number of 20s because notice that that's what we're given in words. So the number of 20s, y, is 6 more than 3 times the number of 10s. So if we take the number of 10s and multiply it by 3, add 6 to that, that's going to give us the number of 20s. So that right there, y equals 3x plus 6, or you could say the number of 20s is 3x plus 6, right? So that's an algebraic expression for the number of 20s. And then if you want to get an algebraic expression for the number of 10s, you can just rearrange this and isolate for that x. So what we would do, we'd bring the 6 over, so we'd have y minus 6 equals 3x. Divide both sides by 3, so x would be y minus 6 over 3. Okay, so I'm going to write that over here. So the number of 10s is y minus 6, so 6 less than the number of 20s divided by 3, like that. Another way to show this is, and it's actually going to help with number 2, is you could say, you could take this 3, put it on the outside, be like 1 over 3, and then y minus 6 like that. Right? So both of these are the same. Both of them are algebraic expressions for the number of 10s in terms of the number of 20s. So we got the number of 20s in terms of the number of 10s, number of 10s in terms of the number of 20s. So both of these are the answers to number 1. And then number 2, describe an expression in words for the number of 10s. So what we're going to do is we're going to take this and convert it to words because we already have the words for the number of 20s. That's given in the question. But now they're asking us to sort of make like this sentence here, but starting with the number of 10s. So for number 2, we can use this. We could say the number of 10s. And the reason why I wanted to show this format here, because it's easier, I feel, to take this format and put in words, or it's nicer to, than this one. If we use this format, we could say the number of 10s is 1/3 of 6 less than the number of 20s. The number of 10s is 1/3 of this amount here, 6 less than the number of 20s. Now you got to be careful here. It's not 1/3. It's not 6 less. You don't want to write the number of 10s is 6 less than 1/3 of the number of 20s. this here would be wrong. Because this here, if we put this as an expression, it would be 1 over 3y minus 6. But it's actually not that, right? But if we were actually to take this 1 over 3 and then distribute it in the bracket, what we would end up with is 1 over 3y minus 2, because 1 over 3 times 6 is 2. So actually, this could be tricky. This was maybe a multiple choice question. They can actually give this statement here, and that may confuse you. And then what they did was they just distributed, because all three of these are the exact same thing. So this statement here, we can say another possibility is the number of tens is 2, let's write it all in words, 2 less than 1/3 of the number of 20s. So that's another possibility. So you got to actually be careful here, I just realized. So this statement and this statement are the same. And notice the subtle differences here, right? So the number of tens is 1/3 of this bracket, 6 less than the number of 20s. But here we're saying the number of tens is 2 less than 1/3 of the number of 20s. Right? So notice the subtle differences in these statements, but both of these statements are the same. And then notice the difference between this statement and then this statement. Here, with this statement, we didn't distribute that 1 over 3 inside the bracket. So we kept that 6 there, and so that would have been wrong. All right, so either of these statements work. And then if we were to use this, it'd be a little weird. It'd be, the number of tens is 3 or 6 less than the number of 20s, all divided by 3, right? It's kind of, I don't know, I don't like it. But just in case, maybe they give this statement on a multiple choice test. Right? Most likely you're not going to run into this statement, but this statement can come up. So you got to know that you got to distribute there, right? So just be careful. I feel like number 2 is actually a fairly tricky question. And then just knowing to take that 3 out could be tricky as well, too. Just algebraically knowing that mathematical rule right there, right? So just be alert with how you do these. And then number 3, it's not bad. It's just basically solving a system of equations. So in number 3, we're told, first off, let me write what I had. So y is 3x plus 6. I'm going to use this. So for a, in number 3, we're told that the total number of bills is 18. So we know x plus y is 18. And so notice we have 2 equations and 2 unknowns. So we could take this expression for y, sub it in here, so we'd have x plus 3x plus 6 equals 18. This would be 4x, bring the 6 over, 18 minus 6 is 12. X would end up being 3. X is 3, plug it in here, 3 times 3 is 9, plus 6 is 15. So y would be 15. So there are 3 10s, 15 20s for 3a. And then you got to be careful too, because maybe they'll ask for the total value. They'll tell you that what's the total number of bills is 18. What's the total value? Well, you would just take this, multiply it by 10, $30, 3 10s. 15 times 20 would give you 300. So 330 would be the total in your pocket with 18 bills given this information. And then B said the total value is 820. And so what would be the expression for the value? It wouldn't just be x plus y, that's the number. Remember, x and y is the number of bills. It's not the value of them, but we can get the value. We'd say x, the number of tens times 10 times $10 would give us the value of the tens plus 20y, like that. Right, that would be the total value, and we said the total value was 820. So for B, that's what the equation would be, and then we would still have this equation. This equation here stays constant for A and B. So we could plug in this here for this y. Before doing that, notice we could actually take everything divided by 10, make it more simple. So we'd have x plus 2y is equal to 82. This and that are the exact same thing, and then we could take this and plug it in there. Doesn't matter, you get the same answer either way, but just less stuff to work with. So we'd have x plus 6x plus 12 equals 82. 7x is equal to 70, right? Bring the 12 over. X would be 10. So then y would be, plug in the x10 here, it'd be 36. So the number of tens is 10, and the number of 20s would be 36. And then you could check these. 10 times 10 is $100. The value of this is 100. 36 times 20 is 720. So the value of the 20s is 720, and then adding them up gives us that total value of 820.